All right. Okay. So, which of the following variables? Do you have it open and stuff?
Yep, I'm ready.
Number 2. Which variables are quantitative? So, telephone number randomly selected. This is towns, common brands, number of people. So, the number of people randomly selected classrooms and the telephone number. Where would that one count?
I just did the number of people in a randomly selected classroom.
Right.
But yeah, but I mean, yeah, like we can go back or we can watch their video tonight and make sure, I guess. So number 3, I did an observation study because the students had no control over the price of the individual cereals.
Hold on, I'm almost done reading through it.
Okay.
The control over the price. Yeah. Okay. Cool. Number 4. For this project.
So I did, it's not possible to determine without the full data set.
And I would agree with that. Because it really isn't. Alright, number 5. Time to complete standardized. Blah, blah, blah. 7 minutes, and duration of 10. Okay, so using that rule.
So I got 2.5 on this one.
I'm not gonna lie, I forgot how to do these. I had my mind in all this other stuff. So, do we use the applet for this one? Or no? Because 65.90.
I think it's the. This is like, so this is like considered the final. So is it gonna touch base on everything or just like?
I think it'll touch base on, yeah, I guess a handful of things. It said it wasn't necessarily cumulative, but there could be things.
Yeah.
Okay. So how did you do that one then? I seriously forgot how to do this. This is embarrassing. Going back to 669.
Let's see. So I just went back to the there's like a link to the rule. It's back in the chapters. Cause yeah, I forgot about it too. So I don't know. I got 2.5. I don't know.
It's too bad. I'm looking it up real quick and I can. Yeah. In 10 minutes, I'm going to that. Okay. Okay, well, I'll have to come back and remember how to do that, but we can go on to the next one. You got,
Yeah, I was just trying to look and find the rule.
yeah, I'm trying to as well.
But all right, yeah, we can just
Yeah,
cruise
I
on
think
through.
that's wrong. Something so simple. Okay. Let all set approximately 1 million discontinuation template.
So I used the Apple and I got 146.8.
I'm just typing it in real quick.
Okay. Okay. Mm, 46.8. Same. Okay.
Cool. All right. Senior Geologist Research Smithsonian 67. So since n is 2, it wouldn't be normal.
I did skewed right.
Yeah, because it's all going to be, yep, super low. Okay, use this information, blah, blah, blah. All right, so okay, so did you get, oh, that was fine. So you take the 8,550 minus 8,544 divided by the 12, and then 6, oops, Did you get 0.5?
This one, I had a hard time with this one. And, but yeah, that's what I'm coming up with. It's 0.5.
Yeah, because you should take, and it seemed high, but you take the 8550, subtract mu, and then divide it by the standard deviation, right? That's how you get the z-squared?
Yeah. So I think it's right.
Okay, yeah, we can check it later. Oh, we're down to 3 decimal places though. 0, 0. Okay, I don't know. That makes me question it, but
Yeah.
if it is.
Number 9, I got 0.991.
0.9. Um, and you got what?
I got 0.991.
Um, I'm not getting that. I'm getting 0.692.
92.
That's 50. Oh. I'm just something. Are we using the wrong z-score formula? Maybe? Is this one where we have to square root it and then divide by the sample mean too?
Yeah, I think so.
So the square root of 8540 minus 4 divided by 12.
So what are you getting?
No, I had to redo it because I think I even punched it in wrong.
Okay.
Mm, so that's and you got 0.999.
Yeah, 991.
991. How did you get that? Because I'm getting the x minus mu.
So, well, what are you getting? You're getting 661, is that right?
I'm sorry.
What are you getting on it?
I was getting 0.691 or 2.
691.
But I think that. Oh.
Well, I'm doing it the same way I don't know. I think I might just put both of our answers and then just like listen to Kent and
Yeah. How did you do that though? Let's see. Maybe we're using different formulas.
I don't know on this one. This one, my wife helped me on this one, and because she took the class before, and I honestly couldn't even explain it to you.
Okay.
Yeah, I think I'll put both our answers and then listen to theirs and
Yeah.
make sure it's right.
Hmm. I guess Brenton's gonna join in. Maybe he will have an explanation for us and remember how to do it. I guess we can keep going though.
Yeah.
Which of the following best describes the notion of the significance level of hypothesis test? Okay, so
I did the probability of type 1 error.
yeah. Okay, the height of young adult females in the U.S. Six inches. Samples taken 5 ranges. 95% so approximately 95% of 95% confident intervals. Females will contain the true mean. Isn't it that one that approximately 95% of all the 95%?
Yeah, that one, and we are 95% confident.
That the true mean is in between. Okay. Yeah. Okay. Um, yeah, requirements for this the confidence interval test. Isn't the sample size too small?
On this one, I put yes. The distribution of sample means is normal because the data are normal.
Oh, they follow normal distribution. Okay. Yeah, this didn't read that part. Yeah, because it's not the other yes only. So. Yeah. Investigator.
The number 13, I couldn't figure out. So maybe you can.
Let's see. So.
Hello?
Open
Hey, Stephanie and Rhett.
Hey, how's it going?
Good. I don't have everything done, but I thought I would try to be the bridge between the two groups.
Yeah.
So I'll just jump on both times.
Sounds good.
Have you guys gotten past 15 by chance?
We're on number 13.
Okay, cool. That's actually right about where I am. I got up to 15.
Perfect. Yeah, we're on the one about the stop.
Rates of return, S&P.
Mm-hmm. So the p-value. So conducting the
For that, 0.019.
Oh, no, I haven't gotten it yet. I'm trying to figure out which spreadsheet one open.
Hey, Brenton.
Such a great example to me. Happy birthday, Daniel. And he said, thank you so much for your work. I'm amazing, amazing man. You both are perfect for each other and such good examples of Lord's blessing when you strive to do what is right. Congrats to you both.
I take it, babe.
Hey, Brenton, have you started the test or the group quiz?
I haven't. Are you guys already on the group quiz?
Mm-hmm.
Yeah, it's exam reviews. So
Yeah.
Wait, what did you say the p-value when you did the hypothesis test?
0.019.
Huh. What? Which spreadsheet did you put it in? Maybe
One sample t-test.
Yeah, that's what I did.
Brett, what do you get for that?
Which one are we talking about?
We're on 13.
13. Yeah, I had a hard time with this one.
Because I put the information in and it says the p-value should be 1. That doesn't make sense.
Wait, say it again.
It's when you put in the information in that spreadsheet, the p-value should be 1.
Well, p-value can't be 1.
Well, yeah, I know. That's why I'm confused.
Oh, what's your null hypothesis?
I'm sorry?
What did you put in for null hypothesis?
Oh. There we go.
I want to make that 0.95 because that's the known mean return for the S&P.
The null hypothesis.
So confidence level should be 0.95.
Oh,
Null
0.95.
hypothesis should be 0.95.
Okay. And then, okay, so now I'm getting 0.98.
Well, you must be doing a greater than test. You want to do less than.
Oh, I thought it was Nope, you're right. Less than.
And well, tell me if you agree, but it seems to me that the problem is talking about to determining if the investor's portfolio performed significantly worse. Well, if the mean performance was a 0.95 return, then we should probably look at less than that, right?
Right.
Rhett, do you agree with that, or do you have a different idea?
What did you guys get on it?
0.019.
19. Yeah. Okay. Yeah, I agree with that. So, Kent, what did you get on number 8 and 9? I got a
Okay,
hard
for
time.
8, I got 2.236. What'd you guys get?
We 0.05.
Well, let me read the question. Suppose that a single volume sample of 20 tanks. So we know that that 12 gallons is the standard deviation.
Mm-hmm.
So if we're doing 20 tanks, the standard deviation is going to be less than that. So it's going to be closer to the 85-44. It's going to be tighter on that.
Okay.
And so if you're looking at what's the chance? Well, we don't say chance, right? But what is the probability of having a 20 sample size that hits 85-50?
Yeah.
Well, that's pretty big. I mean, it's within one standard deviation for one sample, but for 20 samples, I think your standard deviation falls to like less than 2. So it's pretty improbable. Or in other words, your z-score's got to be pretty high.
Yeah.
So the way I did it, though, well, I don't have my math in front of me, but I would say that your answer definitely, the ones that you guys worked out, I'd say doesn't make sense.
Yeah, for sure. So number 9, did you get 0.991?
I did, yep. So that I did get.
Okay.
Is that what you guys got?
Yeah.
You might want to work out the math again for question 8, though, if you guys got something different, just to make sure. I think my answer might be closer to what it really is, but we might want to crunch the numbers again.
Alrighty. Well,
Any other questions, Rob?
we were.
I actually have that math if you guys want to know what it is.
Yeah, go ahead.
So on that one, you're going to do 8,550, then you're going to subtract mu, which is 8,544. Then you divide it all by the standard deviation of 12, and then divide that by the square root of your mean, or the square root of your sample size, which is 20, and I got 2.236.
Okay, cool. So we did get the same answer.
That makes sense.
Thanks for that.
But on 13, I did not get a sample, or the same answer that you guys did.
Yeah.
So how are you doing?
I plugged it into the one sample t-test, and I got 0.12827.
Oh, and I think you're right. Wait, hold on. I just realized I pasted my data in funny, so don't go with my stuff. That's the rates of return spreadsheet, right?
Yep.
Let me repaste this data and see what I get.
I'm still not getting that. What did you get? I got 0.0194.
I got 0.128, and there's 39 sample sizes. Or 39 sample
Do
sizes.
that one more time?
0.128.
0.128. What am I plugging in?
Actually, I'm not getting that. What's your null hypothesis? What'd you plug in?
I have 0.
Oh, well, the null hypothesis is going to be 0.95 because that's the S&P. That's the S&P's known population mean return. Right?
Okay, so it's not the confidence level. Is it 0.95 as well, or does that not?
Well, yeah, that's just. I think that's just a coincidence. But yeah, the confidence level is 0.95, but the S&P has a known population mean of 0.95.
Okay, well then I got 0.0193.
Oh, okay.
Right, that's what I have.
All right, perfect. So it would be 0.019 after we round it.
Yeah.
Right.
Okay, good. I was a little confused. Alright, financial economists is studying married couples.
Are we on 14 now?
Yeah, so shouldn't you be an independent?
Well, because the husband determines which wife, or the wife determines which husband is being used, I'd say they're dependent, right? Because these are married couples, so if you choose one wife, you've got to choose her husband, not just some other husband.
Mhm.
Alright.
Yeah, I agree with that.
So I put B, or the second answer.
Yeah, dependent sampling. He needs to select couples for a sample, so whether a particular wife is included depends on whether her husband is included.
Right. Okay.
So question 15.
Mhm.
Pressures of supply and demand act directly on the prices of airline tickets. As the seats available on the plane begin to fill, airlines raise the price. If seats on a flight do not sell well, an airline may discount the tickets or even cancel the flight. Ali Henrich, a BYU Idaho student, wanted to determine if there is a difference in the price tickets listed 90 days before a flight compared to 14 days before the same flight. For her study, she compared the prices of one-way flights from London's, Heathrow Airport to various destinations in Europe. Using Travelocity.com, she recorded the lowest published fares for 90 non-stop midweek flights 90 days in advance, and then found the lowest published price for the same destination, again, 14 days in advance. The prices in US dollars are given in the file, direct flight costs. Notice that for some destinations, flights were not available. So I plugged the data into my paired sample t-test, and I got a p-value of 0.096.
I agree with that.
I'm still waiting.
Let's see here. And the null hypothesis for that one is just
Well, I guess that they would be the same price would be the null, that there's no difference, in other words, zero, null hypothesis.
okay, and you guys are getting 0.0956.
Yeah, I'm getting 0.096 to round it.
Okay,
Yeah.
that's what I'm getting as well.
And then based on the results of the test, can you say that there is a difference in the cost of airline tickets purchased 90 days in advance compared with 14 days in advance uses? A level of significance alpha equals 0.5. Using that alpha, I don't think we can. We cannot reject the null.
If there's a difference listed.
Because the p-value is greater than the level of significance.
Yes.
Do you guys agree?
Yeah.
So we're asking.
So A for that one.
So no, p-value is greater.
Yeah, p-value is greater. Because p-value is 9% and our alpha is 5%.
Real estate company. Real estate.
All right. Question 17 says a real estate company wants to evaluate. Can you guys hear me? Or is it-
No, I can hear it, but should I mute it again?
Yeah, I'm getting an echo. It says a real estate company wants to evaluate 2 of their home appraisers for consistency in preparation for their annual state certification. It is important that different appraisers be able to give similar estimates for homes and other properties. The company selects a random sample of 10 homes in different neighborhoods around the city and independently asks each appraiser for an estimate of the home value. After they receive the estimates for each home, the company subtracts the value given by the first appraiser from the value given by the second appraiser. They create a QQ plot of the differences and see that the points in the plot roughly form a straight line. Are the requirements for using the desired confidence interval satisfied? And I would say yes, because the distribution of means is normal because the data have been determined to be normal.
I agree with that.
I tentatively agree. I'm just reading over it again just to make sure.
All right.
Yeah, I guess. I mean, they determined it was normal, so. Yeah, they roughly follow a straight line, so I think I'll go with that.
No, you know.
Alright, number 18?
Yep.
Now, suppose the company of the previous question wants to use the hypothesis test to determine whether the estimates given by the 2 appraisers are different. Which of the following would be the most appropriate pair of hypotheses for the test? So they want to see if they're different. So wouldn't it just be that first one? That they're, oh wait, yeah.
Since we're measuring
mu1, mu2, mu1 not equal.
yeah, mu to the d is what I would go with, because technically we're measuring if they're equal. Mu1 equals mu2, but the way we structure this would be a difference, which would be mu difference equals 0.
Yep.
Oh, so mu difference equals 0, mu does not equal 0?
Right. We had actually a case study during one of the office hours, and he had talked about a question like this and said that we structure it just that way. In fact, if you look at the paired sample t-test,
Mm-hmm.
because this is a paired sample, right? We only have two
Oh, and
people.
it even says in there that the null hypothesis is mu d equals 0, so. Okay.
All right, so 19. Suppose you create a 95% confidence interval for the mean. You get negative 2.346 and 8.775. You've been told to report this by saying we are 95% confident that the true mean is between negative 2.346 and 8.775. Exactly what does this mean? I think it's 95% of all 95% confidence intervals actually contain the true mean.
That's what I put.
I agree.
Cool. Okay, number 20. If p is 4 over 5, what is the smallest value of a sample that satisfies the requirements for the normally distributed p?
Hey guys, so before we go forward, just real quick, with that real estate one, do you agree that they're paired, or is it a two sample t-test? Because that's going to give us the answer to question 18 for sure. Are they dependent or independent samples, or are they paired, or you know what I'm saying, right?
Yeah.
Paired
Right.
And you're talking about question 17, correct?
Yeah, the
Yeah.
question 17 text.
I feel like it's paired because they're basing, they're giving their appraisal value based off of both of the rates, like the estimates for the different neighborhoods and one different homes.
It's the same two appraisers for every appraisal, right? Okay, I just wanted to make sure I got that right.
Yeah.
Sorry.
It's okay. Okay. So on 20, that was forfeit. We do oh, how do we do this one? I can't remember.
You have to keep plugging it in till you see that n times by p is greater than 10 and n times by, or p times by n minus 1
There's
is
a
greater
specific
than 10.
formula that we use to find the best n.
Yeah, I can pull up my tool and see if I can figure it out quick. One sec.
So I guess, I
think it's
mean,
50.
13, you get, if you multiply 4 over 5 times 13, it's 10.4.
Yeah, but it also has to be done for n parentheses 1 minus p is greater than or equal to 10. And I got 50 for being the smallest one that works with both of them.
I got 50 as well.
Okay.
Man, I can't find that blasted tool. Where do we get these things downloaded again?
I just got it out of lesson 16. I wrote all my notes in, and it's lesson 16, describing categorical data.
I don't want to hold up the group. So you guys are putting 50 there. I'm going to revisit that myself later. Make sure I understand that. So 50 is the minimum?
Uh-huh.
Okay. Thanks.
The two equations are n times by p is equal to or greater than 10, and the second equation is n parentheses 1 minus p is equal to or greater than 10.
Now that makes sense because if you had 50 and 4/5 of them were there, that means you have in one category 40% or 40, which would satisfy, but in the other category you'd have 10. And anything less than that would not work. So I actually agree now that I have my head wrapped around it. Thank you.
Yeah.
Brett or Brenton, do you want to take 21?
Yeah, it says question 21. Your little brother has a career batting average of 0.233. You want to determine the probability that he will have a batting average of over 0.250 next season when he will be up to bat 40 times. Are the conditions met so that the sample proportion will be approximately normal?
I think we have to take the. Do we take his history or our hypothesis and do the math with that? I know it's the same equation. I forget
I believe it's the hypothesis. And if it is the hypothesis, then yes, because 0.250 times by 40 equals 10, and 40 times by 1 minus 0.250 equals 30. And that would be question B.
If we do it with the history data, it's not going to work out the way, is it?
No, it's not. But if you do that with the career batting average, if you look at the last question, it says greater than 10, and that sign needs to actually be switched the other way and have an equal to or greater than, so that can't be your answer to begin with.
Good call. Well said. Well done. So yes, 40 times 0.250 is greater than or equal to 10.
Mm-hmm.
Okay.
Okay, genetic tests. Geneticist takes a simple random sample of n equals 140 gamete cells from the testes of a dog to determine the proportion which contain the chromosomes for development into a male. Assume the unknown true proportion of the dog gametes that contain the male chromosome is 46%. The geneticist conducts her survey and calculates p hat is 0.512. Which of the following is the most correct interpretation of this statistic? Okay, so what was p hat again?
I think the last one on my quiz, do you guys agree? 51.2% of all the gametes in the sample have the male chromosome.
Yeah, because p hat is the sample proportion, so.
Yeah, I agree with that.
That's what I have on mine as well.
All right. 23. Researchers published a study in which they considered the incidence among the elderly of various mental health conditions such as dementia, bipolar disorder, obsessive compulsive disorder, delirium, and Alzheimer's disease. In the U.S., 45% of adults over 65 suffer from one or more of the conditions considered in the study. Calculate the probability that fewer than 320 out of the 750 adults over 65 in the study suffer from one or more of the conditions. Under consideration, give your answer accurate to 3 decimal places, decimal form.
Hey, I actually have to go because I have institute, but is anyone going to be on later tonight before the quiz?
I was going to bridge it, Brenton, so I'll be on with Dan and you later. Just let me know when you guys want to do it.
All right, sounds great. Thanks, guys.
Yep.
Okay, so 320.
Are you guys getting 0.0996?
Not quite there.
Okay. Actually, it rounds to 0.100.
Yeah, that's what I'm getting. 0.100.
Hold on. Also, do the backwards. Here we go. 0.100. Here we go. Okay.
Does that look good, Stephanie?
Yeah. We got it. Okay, so suppose your testing rule is p equals 0.62 against alternative p is not equal to 0.62, and you've calculated the test statistic to be z is 1.334. The area to the right of z is 0.091. Which of the following is the p-value for your hypothesis test? Okay.
So I think our p-value is 0.091, right?
The p-value is 0.091?
Isn't the p-value
The area to the right of it.
oh no, it's area to the right. We gotta double it then because it's a not equal to.
Right.
So we just have to double that number, which would be 18.2, so 0.182, right?
Yeah, I'm on board.
Okay, cool.
Is that what you guys got? 0.182?
Yeah, 0.1.
Okay.
Yeah, it's a two-tailed test, so they gave us one of the tails, we just need to double it.
Okay.
Suppose you are a dog breeder and you want to use a confidence interval to estimate the true mean fertility levels of purebred Cocker Spaniels. It is known that the distribution of fertility levels of Cocker Spaniels is normal. How many measurements must you have in order to be sure the sampling distribution of X is normal?
Isn't it anything? Or is it at least 5?
Yeah, any will do.
So yeah, any n will do, as long as we know that it's normal to begin with, right?
Right.
Yeah, I agree with that.
Okay, cool. I get all these rules for all the tests confused because some things have to be 5 or 10.
So many different ones. Okay, a study is planned to compare the proportion of men who dislike anchovies with the proportion of women who dislike anchovies. The study seeks to determine if the proportions of men and women who dislike anchovies are different. A sample of 41 men was taken, and the p-hat estimate for the true proportion of men who dislike anchovies was determined to be 0.67. A sample of 56 women was also taken, and the p-hat of that proportion was 0.84. Are the requirements satisfied to perform this hypothesis test? Why? Okay, yeah, again with the rules. So,
I just need to find that dumb that file.
Okay. I think no, because at least one case n times 1 minus p is less than 10 on the women's. Because 1 minus 0.84 times 56. Would you guys agree with that?
I'm just trying to find. Can anyone send me a link to this? What is it? The category or categorical data tool,
Let me see.
or just guide me on how to find that? It's driving me crazy.
The quantitative Excel chart?
Not the quantitative Excel, but the categorical, right? For proportions.
Sorry, you keep cutting in and out. Do you want the spreadsheet link or the?
Yeah, the spreadsheet link.
Okay. Okay, hold on. Let me see. I think I can get you. Okay, if you can't, do you still have your lesson 24 thing open?
I do, yeah.
Yeah, if you go to that and on the side where it says the BYU Idaho and then go to data files, you should be able to access the zip file there to open up all the links.
Okay. Thanks for opening that up. Oh, that's just all the data files. What about the actual analysis?
Yeah, but at the top, there's so hold on, let me click on it. So right before it says download all the data files, it should still, if you have the Excel data files.
Oh, I see it. Yeah, thank you.
Yeah.
That was driving me crazy. Thanks so much.
She just asked me. We are going to know if Rick was coming over here or something. We're going to go with them.
Did you find it, Kent?
Yep, I found it. I'm just plugging in the numbers now.
Hello.
So you got D, Stephanie.
Yeah.
Okay, I agree with that.
Okay.
What's there? Oh, that'd be
Okay, I plugged it in. So no, because in at least one case, n times 1 minus p hat is less than 10, right?
Yeah.
Okay, sorry about that.
Nope, it's okay.
I'm good to go.
Alright, want to take over 27?
Sure. A study was conducted to measure the effectiveness of a diet program that claims to help manage weight. Subjects were randomly selected to participate. Before beginning the program, each participant was given a score based on his or her fitness level. After 6 months of following the diet, each participant received another score. The study wanted to test whether there was a difference between before and after scores. What is the correct alternative hypothesis for this analysis? Each person was given a score based on.
So, kind of like what you said earlier, UD is not equal to 0. The difference.
Yeah, I'm just checking now on the spreadsheet. Paired sample test is, yeah, it's equal to 0, and alternative would be not equal to 0. So the alternative would be not equal. UD. I'm sorry.
Alright, Brad, do you want to take 28?
Yeah. So you guys got B on that one, 27?
Yes.
Okay.
UD equals 0. It's not equal to 0, I mean.
Okay, 28. Weight Watchers wanted to predict how much weight a client would lose if they followed a prescribed exercise program in addition to their diet program. Volunteers were randomly divided into 2 groups. One group dieted but didn't exercise, and the other group dieted and followed the exercise program. For the exercise group, they did linear regression with percent compliance with the exercise program as the explanatory variable and pound loss in 3 months as the response variable. one of the clients was told that his residual was 5.5 pounds. What does this mean?
Okay. So,
Well, this is getting into some of the latter lessons, right?
yes. Finally, some of the stuff we've been working on. Okay, so the residual means that it's the difference from with the y. So like, didn't it say that the residual was y minus the oh, what was it?
Well, it has to do with how much something varies from the intended line or the intended path, right? So if he didn't go on this regimen, so volunteers were randomly divided into two groups. One group dieted but didn't exercise. The other group dieted and followed the exercise program. For the exercise groups, they used linear regression with percent compliance with the exercise program as the explanatory variable. So the exercise program was the explanatory variable. So that's the path I think that we're. And pounds lost in the response variable. One of the clients was told that his residual was 5.5 pounds. So I mean, he would have had 5.5 pounds difference from what he was. I just trying to figure out which one of these it is.
Right, the difference up or down. Well, if he's in the exercise group,
I'm just going to go look at some alligator data just to get my head wrapped around it.
Would it be possibly the last one? Because if it was higher than it would have been if you didn't exercise, it would apply a difference, right?
Well, it doesn't say what group he was in, right? Volunteers were randomly divided into two groups.
Exercise group. It says for the exercise group, they use the linear regression with percent in the exercise program as the explanatory variable and pounds lost in 3 months as the response variable. So if you're taking the explanatory, so compliance with the exercise program versus the pounds lost and the residual between, so the difference, I guess, with those, meaning if the difference was 5.5 pounds, then that means the compliance.
Wouldn't his actual weight loss
Pounds
of
lost.
5 pounds be higher? So he actually lost more weight than he would have if he didn't exercise. That's the one that I was gravitating toward.
Right, that's what I was thinking too, because I'm trying to play it through my head.
Right. Do you have any ideas about it?
I think it's C.
Right, that's what I just mentioned. Actual weight loss was 5.5 pounds higher.
Yes.
It's almost like talking about double negatives. We're talking about weight loss, but his weight loss was higher, which is kind of the opposite of losing weight. It's a little confusing, but I think that's the right answer.
But it says the compliance with the exercise program, so the anticipated value minus that, like the variable and pounds lost in 3 months as the response. So wouldn't that actually be the predicted weight loss was 5 pounds higher?
Well, I'm just going to throw in some data here. So explanatory variables. I'm just going to put 100 pounds just across this as the explanatory variable, and that's the group that is one group dieted, but didn't suffer. So for the exercise group, they use linear regression with percent compliance with the exercise program as the explanatory variable and the pounds lost in 3 months. as the response variable. So pounds lost, we're just going to say they lost 5, 6, 7, 8, 4, 3, 2, 1, whatever.
So I need to go in a couple minutes. Can we
Okay.
pound out 33 through, or at least try to pound out like 33 through 38?
Okay. So so we're skipping 29 through 33.
Yeah, well, just at least me. You guys can go back, but I would like to work on those 33 through 38.
Okay, that's fine. Let's do that. Let's do the 33.
For the next two questions, compute the y-intercept and the slope of the linear regression line used to predict the price of tickets 14 days before a flight based on 90 days. Okay. There must be information here that I'm missing. Where's the data for this? Oh, here it is. Direct flight cost. Got it.
Where's the data for that?
It's up a few questions. I think we might have already downloaded it for some earlier question. It's the direct flight cost data.
Yeah, let's just start on 31. That way we can just start with the data.
Okay.
Okay.
Oh, here it is. Direct hits. Yeah, we have used this before. So the y-intercept, are you guys getting negative 17.087? Did I do that perfect?
I'm just making sure I have the data pasted in the right order.
90 days is x, and 14 days is y, right?
Well, if that's right, then I pasted my data wrong.
Oh, maybe I did mine. Well, no, I did it actually. Rhett, what did you put in correctly?
I did what you did.
So you have 202.09 on the right side and then 234 on the x.
Yeah.
Okay, I gotta switch my data. Where are you seeing that in the problem, just so I can read it?
Well, I'm just feeling that because, hold on, they're trying to predict the ticket 14 days before, so the ticketed price listed 90 days before it, so the 14 would depend on the 90 days, so I'm just thinking 14 should be y and 90 should be x, right?
I'm just looking that over.
Oh. Good.
I guess she did the 90 days before. She did that first, right?
Yeah. Okay, so now if you put it in that way, if you have a very large y-intercept, like a 115.64, right?
Um. So I guess what are you getting as your answer?
For which one? For 31?
Yeah.
Correlation coefficient is 0.78.
Yeah. That's what I'm. Yeah. 0.780.
Yeah.
That's what I get. Yep.
Okay.
And then create a star plot.
So if the answer to the rest is space. So,
So I'm going to create.
I feel like it's pretty really linear.
It actually.
I guess it could be. It would be linear with a strong. Oh, no, wait.
Oh, never mind. I'm looking at the residuals.
Barely. With
They're
a
not there.
fairly strong positive association.
That's what I'm getting.
Yeah.
I agree. There's an outlier or two, but I'd say that's right.
Okay.
But don't the outliers affect? So would you say fairly strong? Is that what you said? Positive?
Fairly strong, yeah. Fairly strong positive. The outliers wouldn't.
Well, the outliers are a big deal in these, but there's only one, so hopefully, there's no other good answers besides the one we gave.
No. Okay, so then the y-intercept concluded to be 115.640.
That's what I have. What do you get, Matt?
Yeah, I agree.
And then what is the slope? Slope
0.627.
Yeah.
And then predict the flight of tickets listed 14 days before a flight based on the same flight costing $200, 90 days before a flight. Give your answer accurate to one decimal place. Predict the price of tickets 14 days before a flight based on the same flight costing $200, 90 days before the flight. So now we can type in for X. We know it costs 200 in the spreadsheet. So our predicted would be 240.979.
Yeah.
Well, one decimal place would be 240.0.
40 point.
Is that what you guys are getting?
Yeah.
Yeah.
Oh wait, 241.
Right, because rounding is going to
Okay.
bump it up to the next dime.
Questions. Construct a 95% confidence interval on the slope of the regression line obtained when 90 days before the flight ticket is used to protect 14 days before. Construct a 95% confidence interval. So the low confidence interval. Confidence interval. Which confidence interval are we looking at? Are we looking at line or slope?
I guess we're probably looking at the confidence interval from mu y, right? Or wait. So I would go to the you're looking right now at the for the unstandardized coefficients area. If you go down below that.
So the one for the regression response?
Yeah, I think that's what we want is, let's see, because they're saying for the construct metaphors for the slope. for the slope of the regression line.
So, okay, so
No,
the
we're
lower
doing
bound
the
is
slope. I guess we're doing the 0.518, right?
one more time.
I think for the slope we're doing 0.518. It's asking for the confidence interval for the slope of the regression line.
Oh. So it would be 0.519, because actually, if we rounded up, it would be 519.
Oh, I'm getting 0.518. Right from this.
Did you move your decimal points over to check?
Oh no, it's just giving me the rounded answer already to the 3 decimal points. Your box doesn't show 0.518?
It does, but then when I move it over a decimal point, it's 0.518 flat. So it should not be 0.519.
Oh, well, it depends where you start your rounding. Yeah, I mean, I can see where you're getting that. It's 0.51845, right?
No, I got 0.515.
Huh.
Oh, I get, well, they just do one more point over it. Nah. Okay, so I guess you're right. Okay. 518.
Sorry, what are you getting, Rhett?
518.
Okay, cool.
Yeah.
So then the upper bound would be 0.735.
That's what I get. 0.735
Yeah, for upper bound.
for the upper bound, right?
Okay.
Yeah, determine the margin of error for this line to the confidence interval. Margin.
If it doesn't show margin of error, we can figure it out just by taking the 0.518 plus the 0.735 and dividing it by 2. I'm sorry, yeah. Or just taking the difference? Yeah, taking the difference and dividing that by 2 would be the margin of error. So 0.518 minus 0.735 divided by 2. I'm getting roughly 0.109.
I'm getting 109.
Yeah, I agree.
I'm sorry?
I agree.
Alright. Next question. The hypothesis test term is is not equal to 0. So if it's not equal to 0, choose the correct null and alternative hypothesis for this analysis.
Well, actually, guys, if I do the math again with the decimals carried all the way out, I actually get 0.1082. So I'm going to change mine to 1.08, but I think that we're close enough that it'll give the right answer either way. But what do you think?
Yeah, I think 108 is probably a better answer.
Okay, 108.
Okay.
Okay. Okay. Alright, so for this next one, if the slope is true, so that's B0, B1. So the null should be, B1 is 0, and then B1 is not equal to 0?
Yeah. Yep, I'm getting B.
Okay, yeah, I agree.
And the value of the test statistic. Based on the same information? Are we using the same spreadsheet that we just put together?
I think so.
Okay.
Yeah, it must be.
Seems like it. Okay, so the test statistic is where is it? Of the slope. 11.510 for the slopes.
Well, the test statistic is R, right? So 0.780. Is that what you guys are getting?
I thought. Mm,
Isn't that the test statistic?
no, that's what we had earlier.
Oh no, I'm sorry. Yeah, I see the T. I don't know what is the R. Oh, that's the regression or something.
Yeah. So, I'm getting P for the slope is 11.510.
Say that again.
11.510?
And why are we doing it for the slope and not the intercept?
Well, because the question, it says for the next question is use the hypothesis to determine if the slope is the true linear regression.
Oh, I see. Okay.
So I think you should do that
So
one, right?
11.510, right?
Yeah.
Do you agree, Rhett?
What are you guys getting? Sorry.
11.5.
11.8.
Oh, you
For
got
question 40, I'm getting 11.510. You're getting 11.8?
No, sorry, I just couldn't hear it. Echoing. So 11.510.
Yep.
Okay.
Okay. And then the p-value is really small. 0.000. What do you guys think?
Yeah, 0.000.
Yeah.
Yeah, I agree.
So what decision do you make based on the p-value and level of significance 0.05, and thus what do you conclude? So we reject the null, and there is so there's sufficient evidence to suggest that the linear regression line does not equal 0. We conclude that there's a linear relationship between 14-day tickets and 90-day.
Yeah, I agree with that.
Okay.
So third one down?
Yeah.
See.
That's what I have.
Well, thanks, guys. I gotta take off, so
Okay.
Thanks, Rhett.
I'll probably listen to your meeting just to double check.
Okay, yeah. I'm probably not gonna submit time with the other guys too. But yeah, thank you. Appreciate
Yeah.
it.
Thanks. I'll see you, or I'll talk to you later.
Okay.
Bye. Kent, do you want to whip out the rest of these real quick?
Sure.
As well
Sorry.
as
Are you still echoing on my end, by the way?
I'm sorry?
Do you still echo when you talk?
No, not as much. Nope.
Okay,
Just a
cool.
little.
Well, I'll keep it on mute when I'm not talking then.
Okay. All right. So 43. If in the U.S., mothers who live in poverty generally have babies with lower birth weight than those who do not live in poverty. The mean birth weight for babies born in the U.S. to mothers living in poverty is approximately 2,800 grams. The CDC carries out a study to test the effectiveness of new prenatal care program in reducing the number of low birth weight babies born. For the study, 30 mothers, all of whom live in poverty, participate in the program, and birth weight data is recorded for which hypothesis test would be most appropriate for the study.
I think we would
I'm
do
really bad.
the mean birth weight for babies is 2,800 grams, so we know that, and they're studying just poor moms and those birth weights. So I think the hypothesis test would be
One sample T.
it's gonna be a T for sure. It's gonna be one sample. I'm just looking it over, but it's got to be a one sample T. That's the only one that would make sense.
Yeah. Yeah, because none of the other ones really apply. I forgot though. Which one is the one sample V test? When do you use that?
We would use that if they gave us a theta or a sigma.
Okay, right.
Standard deviation, but they don't in this case, so it's got to be a T test or some variation of it on it. Yeah, so I would say one sample T.
Okay.
And then question 44, engineers at an oil refinery find out how easily gasoline evaporates by measuring its vapor pressure. As they make gasoline, they need to determine whether its vapor pressure is high enough. The standard deviation of the vapor pressure of the gasoline made by the refinery is always 0.03 pounds per square inch. So we know the standard deviation. Which hypothesis would be most appropriate for this task? So I would say the one sample Z test.
Very good. We just talked about that. Great. 45. An attorney wants to know whether the percentage of Walmart employees and employees who are over 45 is more than 30%. Which procedure would be most appropriate for this solution? Over 45.
I would say a test of one proportion because we're just comparing it to 30%, which is their hypothesis.
Right. And it doesn't really give us anything else, so. Okay, I'll take it. Marriage counselor conducted a study of couples, categorizing each of the couples as communicative or non-communicative. Among other things, the counselor wanted to see whether the percentage of communicative couples whose marriage ended in separation or divorce was the same as the percentage for non-communicative couples whose marriage ended in separation or divorce. Which hypothesis test would be most appropriate for this study? So let's see, the percentage. So the proportions. So test of two proportions?
That's what I would say. Yeah, because we're checking percentages and there's two groups involved. So
Right. Okay. 47. A business marketing firm specializes in radio advertising. They hope to show there is a linear relationship between sales and the amount of money a client invests in radio advertising. Which procedure is most appropriate? So the linear regression, right?
they hope to show there's a linear relationship between sales. Yeah, so it's a linear regression.
Okay.
Now we got to go back to
Back to one.
what, 28ish or something.
Oh,
I think we were hashing out 28 when we moved forward about the Weight Watchers.
yep. 29.
I'm just if
Oh, wait, 28. I'm not sure of 28.
if you don't mind, I just want to read through it again quick.
No, that's fine. Me too.
Weight Watchers wanted to predict how much weight a client would lose if they followed a prescribed exercise program in addition to their diet program. Volunteers were randomly divided into two groups. One group dieted but didn't exercise, and the other group dieted and followed the exercise program. For the exercise group, okay, so now we're narrowed down to that group, they used linear regression with percent compliance with the exercise program as the explanatory variable and the pounds lost in 3 months as the response variable. One of the clients was told that his residual was 5.5 pounds. So
okay, so the residual was the difference?
Yeah, it's a difference, but the residual was positive. So if he had a residual of 5.5 pounds, wouldn't he actually weigh 5.5 pounds more than what was expected? But to be sure, I'm just going to put in 100 pounds, and then the response variable was 5 pounds lost. 115 pounds with 4 pounds lost. 112 pounds with 3 pounds lost, let's say. I'm just trying to look at what these numbers show. 150 pounds with 7 pounds lost. 180 pounds with 9 pounds lost. Okay, so when I plotted these out, the residuals that are positive, this is going to be the 1.4. So it's going to be the 5. So that one's. So the residuals are that are positive meant that they lost more pounds than others. So what's confusing about this is we're measuring pounds lost. So actually more pounds lost. If he had a residual that was positive, he lost more pounds than what was expected.
So it was his actual weight loss was 5.5 pounds higher than the predicted weight loss.
Yeah, then I would say the predicted weight loss. I don't think it has anything to do with if he did an exercise. I would say his weight loss was 5.5 pounds higher than his predicted weight loss.
Okay. Yeah, that makes a little more sense now that we kind of planned that out.
Okay, so now I feel better about that because I think we had C before.
Yeah. We're kind of on the right track, but still.
Well, it throws us off because they mentioned that other part of the study, which wasn't a part
I know, I hate it when they do that.
of the linear regression thing that they were studying. So anyway, I think we're on the right track with it.
Okay.
For the study in the previous question, the B1 of the regression line was 5 pounds. Interpret the statistic. So that's the slope. So for every
His compliance goes up by 1% on average, 5 pounds are lost in months.
the average on average exercise participants lost 5 pounds more than no as percent compliance is up by 1%. No, not enough. Yeah, what is going on with this? I got to get my head wrapped around this thing again. 1 second. I'm going to read this silently.
Well, the first two don't make sense though. Because slope is not the average. So
No,
it wouldn't be the average. And if the average really lost is 5 pounds, that wouldn't make sense. On average, you lost more than that. It has nothing to do with that. I think the only one that would make sense is as the compliance goes up, it goes down by 5 pounds. Because that's kind of the relationship of the slope. Because it's minus multiplying that by, let's see if it was 5 times how whatever amount of exercise you're doing, that would be the amount, right?
Yeah, I think we need to revisit 28. I'm reading this question again. For the exercise group, they use linear regression with percent compliance with the exercise program as the explanatory variable, and pounds lost in 3 months as the response variable. So I actually let me just rework this data. I gotta put percentages in there. So if they were if they're 10% compliant, they only lost 1 pound. If they were 40% compliant, they lost 3 pounds. If they were 80% compliant, they lost 5 pounds, let's say. And if they were 100% compliant, they lost 10 pounds or 12 pounds, let's say. And let me see what this data now looks like. All right, so
I think that it is that one. It's C because they're calculating the percentage,
right.
and that would factor into the equation.
So someone a low liar here would be my 0.8 guy. So my 0.8 guy, my 80% compliant guy had a negative residual of 5 pounds. So if I change him to 9 pounds, yeah, he gets back up in line into a positive. If I go back to 5 pounds, he's got a negative residual. Let's put him to 10 pounds. Yeah, so if you have a positive residual of 5.5 pounds, you lost more weight without participating in the program than you should have. So so then his predicted weight loss was 5.5 pounds higher than it would have been. It was 5.5 pounds higher than it would have been if he didn't. His predicted weight, his actual weight loss was 5.5 pounds higher than it would have been if he didn't exercise. I guess that's the right one. It's the only one that makes sense. So yeah, so 29 then, the study in the question B1, the regression line was 5 pounds.
But as a percentage goes up by 1, 5 points were lost in 3 months.
I would agree with that. I'm looking at my chart now, and that must be true. That's the only one that would make sense.
Okay.
So sorry that we're going slow on that. 30.
No, it's good to understand what we're talking about. Okay, let's
So
see. For number 30 then.
Yeah, go ahead.
Scatter plot, residual plot, and QQ. What are the 5 assumptions of linear regression being checked? I think the x values measured without error, right? The residuals are normally distributed and the observation is independent. And there's linear regression between x and y. The variance is constant for all of it. So wouldn't it be just the first 3?
Well, I don't know if, when we look at the scatter plot, residual plot, and QQ plot, remember we don't assume that the observations are independent. That would be a separate sort of idea. I think 3 of the 5 on the last homework that we took were correct. The x values are measured without error.
But there wasn't like the
That one we don't know. The residuals are normally distributed. That one we check.
mhm.
The relationship between x and y, that we're looking for, and the variance of the error term is constant for all values of x. The variance of the error term is constant.
When we're looking at all 3,
What's that?
when we're looking at all 3 of the plot.
Yeah, so when we look at this, when we look at the residual plot, that's when we make our own QQ or our own scatter plot.
Mhm.
That's the one that aligns with the residuals are normally distributed. That's what we're looking for, to see if they're scattered all over, and if they are, it's normal. With the scatter plot or with the QQ plot, we are looking for, I forget what we're looking for there. I think we can also put the residuals in a QQ plot, and we're looking for to see if they're normally distributed that way.
Mhm.
And then, of course, with the scatter plot that's provided for us, we're looking to see if there's a linear relationship between x and y.
Okay.
So the residuals are normally distributed. That's definite. There's a linear relationship between x and y. That's definite. And those charts aren't going to tell us anything about the x values are measured without error, because we're not watching the person measuring things
Oh,
by looking at a plot. And the observations are independent. We have no idea. They could be totally biased. We're just looking at data. We don't look at how it's collected or why it's collected.
Unless they specifically tell us. Okay.
Then the last one, I don't know. The variance of the error term
It's constant for all
It's
values.
for all values, but I imagine that we could deduce that from the chart. I'm gonna look in the lesson real quick.
Okay. Yeah, we can fix it too.
Lesson 23.
If the variance was all constant, though, that would mean that we would have to measure the x as well.
In order to do the hypothesis test, so scatterplot is going to help us. Look at the next. Okay, a megaphone shape occurs when points tend to be close together on one side of the graph and farther apart on the other side of the graph. If there is a megaphone shape apparent in the residuals, it suggests that the variance of the error terms is not constant. So that one we're definitely looking for.
Oh, so we are looking for the variance there.
Yeah, the variance of the error term is constant for all values of x. We'll know that because if there's a megaphone, it's not true.
Okay.
And then we've done all that. So I think that's everything. I have all my answers checked.
Yep, I have all mine as well. I think there's one that I had a question that Rhett and I didn't get to go back and check. I wasn't sure about.
Are you just looking through?
Yeah, there's one that I know I had a question on, but I can't remember which one it is. Hold on.
Take your time.
Oh, it was number 9. No, number 8. I don't remember how to do this because I thought you would take the 8550 minus 8544 and you divide it by the standard deviation, and then what to get the z-score?
Well, remember the standard deviation in this though is more complicated than just taking the 12 gallons, because now that we have n equals 20, the equation changed for the standard deviation. So now the equation is I'm trying to remember it off the top of my head, but you remember it's like 12 divided by the square root of 20 or something like that is the new standard deviation.
Okay.
I'm looking it up now, what the equation is. So the square root of it's the square root oh no, this is proportion. Hold on, let me go to the one mean. Yeah, here it is. Okay, so margin of error.
X minus mu divided by, and then you divide the standard deviation by n, divided by standard deviation divided by n. No, but that would. No, never mind.
I'm opening up the text to try to find the chapter. Yeah, so the new standard deviation is 12, which is the original standard deviation, divided by the square root of n, which is 20 in this case.
Okay.
Okay, and so that's the bottom. That's the bottom part of the equation. The top part is x bar minus mu. So if you take
minus.
yeah, so x bar in this case is 8550 gallons.
And then divided by the mu.
Well, then we have to take away the mu, which is 8544. So 8550 minus 8544. What do you get there? Six, I guess. And then divide that by that new standard deviation, which is 12 divided by the square root of 20.
Okay. So then that gives you 236.
Oh, then what are we doing wrong here? Then I might be doing something wrong. Suppose that a simple random sample of n. So what is the z-score corresponding to the sample mean? So is that what you got before?
Maybe. Hold on. Are we supposed to do the square root of that though? 1.1.
You're supposed to take the square root of 20. I'm grabbing my calculator now to crunch through it.
What did you get for your final answer the first time? Because if I square root that, I get 1.49.
Sorry, ask that again.
What did you get for that originally?
Well, 1 second. I got some background noise. One moment.
Okay.
Okay. Hold on. All right. One last time. Ask that again.
Oh, I was just wondering what you originally got, because when I square rooted it, I got 1.495.
I got 2.236.
Okay. Hold on.
But I'm going to crunch my numbers again because now I'm not confident. Divided by the square root of 20. Yeah, I just did it again. I'm getting the same answer on the calculator. So
There we go. 2.236.
what's that?
I got 2.226.
Yep, that's what I have.
Okay. Yeah.
And
And that is
0.91 for question 9.
then 0.991. I think that's. Okay. Yeah, cool. Do you have any other questions or anything?
No, I think no, I think I'm good. I'll just I'm gonna get back online with these guys at, I don't know, like 8:15 or whatever Brenton's done with his institute class.
Okay.
So I'm gonna just hold off to submit my test until then, so I can just walk through it with them again and
Okay.
see if
I
they.
think I might submit mine, but I'll post this video and then you guys can post yours maybe.
Yeah, I'll tack it on. I'll just do a reply to your posting, assuming you go first.
Sounds good.
Cool.
Do
If
that.
you find any problems with that test, you know, shout it out and let us know.
Well, I can just submit it now and then I'll let you know.
Okay, cool.
that.
I'll hang on then.
I mean, I feel pretty confident about it, but about the things we're doing. You never know. So it looks like we got an A on it, and looking through to see if we missed any. Okay, so it looks like 39 is incorrect. I may have just.
For 39, I have this
The
one.
fancy B or the normal B?
I guess I highlighted the normal B, but
So evidently it's the.
oh, this is linear regression problem. So
Yeah.
it could be the other B.
Yeah, I didn't catch that. So we got that one, that, and then that. Maybe I'm the only one we missed. I don't know. Anyway,
That's about the only one. Let's go through.
21 actually we got wrong as well. So it should actually be no. I thought
For which number?
for number 21, it should be the last one. No, because 40 times 0.233 is less than 10. Which I just, yeah.
40 times point.
233 is less than 10, and that's.
Oh, we got it when we were talking with Brenton. We got it exactly. Yeah, so he said that it was the 0.25 number, or it was the P. What is that? The P hat, or the P. And really, we needed to be looking at the P hat, which is 0.23.
So I guess that we'll just have to be careful about that too. But yeah, other than that, those are the only two that we got wrong.
Well, I came in late. Do you mind just real quick? Question 1, I met with my, oh, never mind. Question 2, which of the following variables is or are quantitative? The number of people in randomly selected classrooms on campus, that's the only one I have checked.
Yeah.
And then question 3, an observational study, because the students had no control over the price of the individual cereals.
Yes.
And then question 4, the median will increase.
No, actually, it's not possible because without the full data set.
Oh, so how do we come up with that? I'm just looking. Oh, is that what those colons mean, that we don't have a full data set? Ah,
So
okay.
because
What the
yeah,
choices were.
it just shows the skipping to the 99, and without the rest of the information, we couldn't determine it.
Duh. Okay. I was confused by what they were trying to demonstrate there. Okay. So question 5, 5.0.
No. We went back in
What's that?
2.5.
So let me read this. So the time to complete a standardized exam with a normal mean of 70 minutes and a standard deviation of 10 minutes. Using this rule, approximately what percentage of students will complete the exam in under 50? Oh, yeah. So it's going to be twice the standard deviation. Well, wait. 70 minutes minus 10 minutes is 60, minus 10 is 50. So there's 2 standard deviations away, right?
Mhm.
So wouldn't that be 5?
No, hold on.
Do the exam in under 50 minutes.
So standard deviations.
Oh, what percentage of students? Okay, so I'm putting in. Well, no, it wouldn't. I don't understand.
Let me read through this. I think that's one that Rat had to talk me through because I was confused. 30 minutes standard deviation. Yeah, so you're right. 50%.
If it was 1 standard deviation away,
It's not the percent.
oh, so wait, what was the answer? 95%?
No, on number 5, the answer is 2.5.
2.5.
So,
We'll complete the exam in under 50 minutes. Oh, I understand why. Okay, so now I see why. Because the total 95% of the data. So we're looking at the second standard deviation, first one being 68, second one being 95. 95% of all people are going to be close to the bell, and the other 5% are going to be distributed equally, 2.5 on each side. 2.5% of people are going to be less than 50 minutes, and 2.5% of people are going to be more than 90 minutes, to make a total of 5% that are outside of the 2 standard deviations. So now I'm walked through that. That makes sense. So I'm glad that we reviewed that.
Yeah, because I forgot how we got there.
And then question 6, 146.8.
Yes. And then did you get 7?
Well, what did you get for question 6?
Yeah, 146.8.
Okay, good. And then 7 skewed right.
Mm-hmm. And then 8, 2.246.
Yeah, and I think this is where we kind of
Oh yeah.
we were working together. And then question 10, probability of a type 1 error.
Yep.
And then question 11, I have 2 answers. Approximately 95% of all 95% confidence intervals. And then we are 95% confident that the true mean height of adult females in the United States is somewhere in our confidence interval.
Yes.
Those are 2, right?
Mm-hmm.
And then 12 is yes, the distribution of sample means is normal because the data are normal.
Yep.
And then I think jumped in.
0.019.
And 14 is dependent sampling.
Yes.
He needs to select couples for his sample. So yeah, and I remember us working on that together. So.
Okay. And then that's about where we because 0.096 or 15. Yeah, that's where we came together.
Okay, cool. Well, thanks for walking me through a few of those. That actually was helping for the exam on that 68, 95, 99.7.
Yeah, no, I got confused on that one.
All right. Well, thanks, Stephanie. I'll let you close this up, and then I'll follow later on with another one.
Okay, sounds great. Thanks for your help. Good luck on the test.
Thank you. You as well.
Thanks. All right.
Yep.
Have a good night.
Bye.
Yeah.